Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuit and today's topic is power supply. And the previous lecture we have discussed the what is power supply and what are the basic principles or the features to choose a power supply. Now what are the important specifications which we use in the power supply? While all the power supply specifications are valuable, some are more critical than the others. So, a few specification of the power supply we will discuss, like output current, the maximum current that can be supplied to the load, that is the output current through the power supply. Next is the load regulation. The load regulation is how well the regulated can maintain its output with a load current changes. So, usually we will measure this in the millivolts or as a maximum output voltage. So, load regulation is used to regulate the output. Next is the noise and ripples. Noise is any added or unwanted electronic interference. So, and the ripple is a small variation in the voltage that AC is transforms into the DC. These are typically combined into the one measurement. In switching power supplies, the measurement is given in the peak to peak, showing to extend the noise that arise from the switching. And next point is the over voltage protection. That is also the important part we will keep it in our mind when we use the power supply. Sometimes output voltage can exceed their nominal value and can damage the load. So, over voltage protection is a circuit that shuts down the power supply and that should the voltage so that it can be used to protect the voltage damage. So, we limit the voltage from its limit. So, next is the overload protection. Overload protection is also a safety measurement which is used to prevent the damage in the event of the short circuit or the overcurrent event. So, like the circuit breaker in the house or like the load protection shuts off the power supply, so the load will not be damaged. Next is efficiency, that is also an important part. Efficiency is the ratio of the power being pulled from the power grid that is effectively being converted to the DC power. A good SMPS power supply will operate with at least 80% efficiency and a proper system design can operate at a higher rates. So, an efficient system will reduce heat generation and can save energy up to the for the more efficiency. Next, now we will discuss the various power supply. First, we discuss that on the basis of the design, we discuss the two type of power supply, in which first is the linear power supply. You see on the screen that this type of gadgets you always see in your laboratory or in your house, that is a linear power supply that we will use for supply the voltage. What is this linear power supply? This is the one type of the electronic power supply that is that provides a stable and regulated DC output voltage, where we use the linear voltage regulation technique just to get the stable and regulated DC output voltage. So, they are widely used for the various electronic devices and applications due to their simplicity, low noise and relatively low cost. And here there are some key features of the linear power supply. First is the load regulation. In this type of power supply, linear regulator, typically a integrated circuit or the discrete components to regulate and maintain the constant output we will use. So, this regulation ensure that the output voltage remains merely constant, as the output will be the constant even when there is a variation in the input voltage or the load conditions, but the output will be the output voltage remain constant. What are the basic components of this linear power supply, which consist of the transformer, rectifier, filter capacitors, linear regulators. So these are the basic components which we use in the linear power supply. As we know, there is a transformer which converts the AC input voltage to the lower AC voltage, right, and another is a rectifier which convert AC voltage to the pulsating DC voltage. Filter capacitors smooth out the pulsating DC voltage. What is the function of the linear regulator? That regulates the filtered DC voltage to produce a stable and the regulated output voltage. So these are the basic components which use in the linear power supply: transformer, rectifier, filter, linear regulator. Next is the efficiency. What is the efficiency of this type of linear power supply? That is, they are less efficient than the switching power supply. Switching power supply is another type of the power supply on the basis of the design. So linear power supplies are generally less efficient than the SMPS because they dissipate excess energy as a heat. So the linear regulator drops the excess voltage across the transistor and dissipating it as a heat, which can be inefficient especially for the high output current or the large voltage differences between the input and output. Another feature of linear power supply is the noise and ripple. So it produces a low output noise and minimal output ripples, making them suitable for the applications where the noise is a concern, such as the audio equipments. So these type of batteries have a less noise and ripples. Voltage adjustment. Some linear power supplies offer adjustable output voltage, allowing user to set the desired voltage with a specified range. So for a specified range we can fix the voltage. Next important feature of linear voltage is the line and load regulation. Linear power supply typically have a good line regulation, the ability to maintain the output voltage with the variation in the input voltage. So load voltage to maintain it is ability to maintain the voltage with the variation in the load current. So line and the load regulation is also an important feature in this type of linear voltage. What are the application of the linear power supplies? As they are having a low noise and precise voltage regulation, and such as these are used in the audio amplifiers, laboratory equipments, analog circuits, and the sensitive electronic devices. These are the application of the linear power supplies. What are the disadvantages? Lower efficiency we have using this linear power supply as compared to the switching power supply, limited in their ability to handle a wide range of the input voltage, generally heavier than as compared to the other power supply, that is a switching power supply, not well suited for the high power application due to heat dissipation. What are the safety features? The same safety feature as linear power supply include the safety features like overcurrent protection, over voltage protection, and the short circuit protection. These are the safety features. If we summarize this, then we can say that linear power supplies are reliable and widely used in the application where precise voltage regulation with the low noise are essential. While they may be less efficient than switching power supply, they remain a popular choice for the various electronic devices and laboratory equipments due to its simplicity and low noise characteristics. So generally in the laboratories we use the linear power supply. Next type of power supply that is classified on the basis of the design is the switched mode power supply, that is a SMPS. You see on the screen here that this is the switched mode power supply. It is just similar to the linear power supply. So SMPS is also an electronic circuit that converts the power using switching devices that are tuned on and off at a high frequency, and the storage components such as inductors or the capacitors to supply power when the switching devices is in its non-conduction state. So switching devices also have ability to store the for the storage storage, and that can be used for the switching as a switching devices. So switching power supplies have high efficiency and are widely used in the variety of electronic equipments that includes a computer and other sensitive equipments requiring stable and efficient power supply. So a switched mode power supply is also known as a switched mode power supply or the switched mode power supply, that is also called. It is also divided into 4 categories according to this type of input and output voltage. So first is the AC to DC, second is the DC to DC, fourth is the DC to AC, and fifth is the AC to AC on the basis of input and output voltage. Define the 4 categories. These are the 4 combination basically we use. A basic isolated AC to DC switched mode power supply consists of what components it consists of? First is the input rectifier and the filter. Second is the inverter, which consisting of the switching devices such as the MOSFETs. Another device it uses is the transformer. Output rectifier and filters it use. Now the next one, which is very important, feedback and the control circuit, that is also in the switched type of devices. So we have the components. First is input rectifier and the filter, inverters that use the MOSFETs, transformer, output rectifier and the filter, feedback and the control circuit. Switching power supply SMPS, which is known as the switch mode power supplies, a type of electronic power supply that efficiently converts the electrical energy from one voltage or the current level to the another voltage and current level. So they are widely used in the various applications due to their high efficiency, compact size and ability to handle a wide range of input voltages. It means we are here, this type of switching, it vary the voltage, a range of voltage we can vary in this type of the power supply. Here what are the key features of this switching power supply SMPS? First is a high efficiency, as there is a very less loss, so efficiency is very high in this SMPS. High efficiency compared to the linear power supplies. They convert the electrical energy with the minimal energy losses, reducing the heat generation. So high efficiency in the switching devices. So switching operations are the core principle of SMA, involves the high frequency switching of the electronic components to control the voltage or the current output. The switching operation allows SMPS to step up and the step down, boost and buck, or invert the input voltage as needed. Another components which we use for the SMPS are switching transistors that rapidly switch on and off to control the flow of current. Second is the inductors, use the energy storage, and the filters here. Capacitors use the filtering and the energy storage. Next is a diode that use the rectification in some topologies, right. Next is the control IC that manages the switching operation and the regulates the output voltage. These are the various components used in the SMPS. Voltage regulation in this type of that maintain a stable output voltage over a wide range of the input voltage and the load condition. They use the feedback also, so they use the feedback control loops to adjust the switching frequency and the duty cycle to regulate the output voltage. Next is the compact size. SMPS typically more compact and lighter than the linear power supplies with the similar output power. So, this compact size makes it suitable for the application with the limited spaces. Wide input voltage ranges, as we can vary the voltages, so the input voltage can vary. So, SMPS can often handle a broad range of the input voltage, making them suitable for devices that need to operate in different region or with varying power supply. Low heat generation, so that efficiency will increase. Due to high efficiency, SMPS generates a very less heat as compared to the linear power supplies, which can be crucial in the application and the thermal constraint. Ripple and noise, while SMPS are efficient, they may introduce some high frequency noises and the voltage ripples on the output, which may require the additional filtering or the regulation, so that the noise and ripples may be minimum. What are the application of the SMPS where we can use this type of battery? SMPS are used in a wide range of application as consumers electronics like laptops, in smartphones and televisions. We use this. Industrial automation, we use this type of power supply. In the telecommunication, we use. In the automotive electronics, we use this. Renewable energy system, solar converter, computer power supplies, we use this SMPS. What are the protection features? Again the same. Protection feature: overcurrent protection, over voltage protection and short circuit protection. We summarize this switching power supply, that is also known of their efficiency, compact size, versatility in the handling various input voltage ranges, their high efficiency, their ability to regulate voltage that make them suitable for a wide range of the electronic devices and the system. Like, however, they may require the careful design and filtering to minimize the output noise and the ripple. They are more efficient as compared to the linear power supply. So, they are widely used in the electronic devices. On the classification of the power supply of this different type, as we discussed, so here we take the sum of the AC and DC power supply. So we take here there are the major kinds of the power supply, that on the basis of like that the unregulated power supply, linear regulated power supply and switching. There is another type of power supply, that is also the ripple regulated, that is a hybrid between the brute force and the switching design and the merits of the subsection of the itself. So, in the unregulated power supply, that type of unregulated power supply is the most this type consists of the transformer, rectifier and low power filter, and this type of power supply typically exhibit a lot of ripple voltage. Ripple voltage means rapidly varying instability. Ripple voltage, that ripple is the voltage in terms of less gain, less, more, less gain, and like that we get the rapidly varying instability and the other AC noise subimposed on the DC power. So, in this type of unregulated, the input, if the input voltage varies, the output voltage will vary by proportional amount. So, the advantages of an unregulated power supply is that it is cheap, simple and efficient. In the unregulated power supply, we do not have the voltage regulators built into them. They typically is desired to produce a specific voltage at a specific maximum output load current. So, this typically block wall chargers and that turn AC into a small trickles of the DC and are often used to power devices such as the household electronics, and they are most common power adapters and they are also called the wall wart. So DC voltage output is dependent on the internal voltage reduction. Transformer should be matched as closely as possible to the current required by the load. Typically, the output voltage will decrease as the current output to the load increases. Here you see on the screen, this is the simple main power supply. This is the unregulated, means mains input power transformer, then the rectifier, then the smoothing, then the output. So advantages of unregulated power supply are that they are durable and can be expensive, and they are best used when precision is not required, and they have a residual repulse. Another type is the linear regulated. What is this linear regulated? That is also called the that is simply the brute force. The linear regulated supply is simply a brute force power supply that followed by 8 transistor circuits operating in the active or the linear mode. So the name is linear regulator because it is working in the active or the linear mode. And linear regulator typically designed to output a fixed voltage for a wide range of the input voltage. It simply drops any excess of the input voltage to allow a maximum output voltage to the load. So this excess voltage drops result in the significant power dissipation in the form of the heat. If the input voltage gets too low, the transformer circuit will lose regulation. So it can only drop excess voltage, not make up for a deficiency in the voltage from a brute force section to the circuit. Therefore, keep the input voltage at least 1 to 3 volt higher than that of the desired output depending on the regulator type. So power equivalent of at least 1 to 3 volt multiplies by the full load current will dissipated by the regulated circuit, generating a lot of heat. This makes linear regulated power supplies rather inefficient. Also, to get rid of all the heat, they have to use large heat sinks, which makes them large, heavy and expensive. Another is the regulated power supply. Unregulated, linear, and now is the regulated power supply. So regulated power supply is essentially an unregulated power supply with an addition of the voltage regulator. So this allows the voltage to stay stable regardless of the amount of the current consumed by the load, provided the predefined limits are not exceeded. You see on the screen here that this is the main input, this is the power transformer, rectifier, again the smoothing. Now you see here linear or switch regulator, then the output, then we are giving the feedback to the linear or the switching regulator. So this is the change from the previous linear output. So regulated power supply is circuit continually samples a portion of the output voltage and adjusts the system to keep the output voltage at a required voltage. In many cases, additional circuitry is included provides the current and voltage limit, noise filtering and output adjustment. What are the advantages of the regulated power supply? As it is having a stable voltage, so regulated power supply provides consistent voltage output, ensuring reliable and the stable performance of the electronic devices. Moreover, noise filtering. Regulated power supplies are designed to filter out the noise and ripples, providing the clean power for the sensitive electronic components. Moreover, it is having a adjustable output. Some regulated power supply have the adjustable voltage outputs, allowing for flexibility in the different applications. Another type is the linear switch and the battery ways that we will discuss further in the next lecture. Thank you very much.